Hello and welcome to the next section of Unit 10. Alright, so today we are going to be talking about quadratic functions in standard form. So this right here is a standard form quadratic equation. So I'm just going to write a random example with numbers. So like if I have y equals 3x squared plus 4x minus 6. This is standard form because there are no parentheses. We just have something times x squared plus something times x, and then minus something. So whenever you see this form, that's standard form, which is not quite as nice in many cases as vertex form. So this thing right here, this equation right here, oops, I kind of crossed off, covered it up. This is going to be a very important equation. You're going to have to remember this basically for the rest of the semester, because we're going to be using this quite a bit. So whenever, this is all, we always use this in standard form. So whenever you see a standard form, you're going to have to know how to use this. So negative b, so that'd be this value with the opposite sign, divided by 2 times whatever a is. So that is how you find the line of symmetry equation. So this will give you an x value. That's how you find the line of symmetry. So remember, the line of symmetry is also the x value of the vertex. So this will also be how we start to find the vertex. So which is what this is all explaining right here. So in example 1, if I need to find the equation of the axis of symmetry and the coordinates of the vertex of the graph for each of these, the first thing I'm going to do, since I notice this is in standard form, I'm going to say x equals negative b divided by 2a. So the b value is whatever is b multiplied times just x. So b is 6. So if I'm taking negative b, I'll have negative 6 divided by 2a. But a is 3, so 2 times 3. So I have x equals negative 6 divided by 6, which is negative 1. So that means x equals negative 1 is my line of symmetry equation. Now, if I wanted to find the vertex, which I also have to do, so the vertex, I'm just going to use b for vertex. I already know the x value is negative 1. I just need to find the y value. If I know the x value, and I have an equation, how can I figure out that y value? Hopefully you're saying to yourself, well, we can plug in negative 1 for x, and then we'll solve for y. So y equals 3 times negative 1 squared plus 6 times negative 1 and then plus 2. So exponents come first in order of operations. So 3 times negative 1 squared. Negative 1 squared is just positive 1. 6 times negative 1 is negative 6 and then plus 2. So 3 times 1 is 3 minus 6 plus 2. So 3 minus 6 is negative 3. Still have that plus 2. So negative 3 plus 2 is negative 1. So that means the y value of the vertex is negative 1. And that's how you find the y value of the vertex. So again, this thing right here is very important. This is the line of symmetry equation. So make sure you remember this little equation. Oops. All right, the next example. So again, we're going to start off with x equals negative b divided by 2a. In this case, b is negative 8. So if I have a negative 8, that just turns into a positive 8. So I can really get rid of that. Divided by 2 times a. So a is negative 2 in this case. So 2 times negative 2. And maybe it'll help you if you just write out a, b, and c. So a equals negative 2, b equals negative 8, c is negative 3. We don't really need c yet. We will use that in the future. So that's just an option if it'll help you stay more organized. So 8 divided by 2 times negative 2 is negative 4. So 8 divided by negative 4 is negative 2. Forgot my negative sign. So this is the line of symmetry right here. X equals negative 2. Now I need to find the vertex. So the vertex, I already know half of it. The x value is negative 2. So I just have to find that y value. So to find the y value, if I have an x value and an equation with x in it, how can I figure out y? Well, I'm going to substitute negative 2 in for each x that I see, and then I'll be able to figure out what y is. So negative 2 times negative 2 squared minus 8 times negative 2 minus 3. So exponents come first. Negative 2 squared is going to be positive 4. Negative 8 times negative 2 is positive 16. Still have minus 3. Negative 2 times 4 is negative 8. So now if I combine all these, negative 8 plus 16 is positive 8. 8 minus 3 is 5. So y is 5. And that's our vertex, negative 2 comma 5. So on these next two, I recommend you pause the video and try these on your own because it's pretty much the same thing that we've just been doing. So it's good to practice on your own, but I'll do them. So x equals negative b divided by 2a. B is 2, so negative 2. Oh yeah, another thing I should say that I forgot to do up here. Whenever you plug in a number for a variable, so whenever you plug in b, always put in parentheses. So I have negative 2 and then 2 times a. If you do not see any number here, that means a is 1. So negative 2 divided by 2 times 1 is 2. So x is equal to negative 1. So here's our line of symmetry. And now to find the vertex, I already know that the x value is negative 1. So I just have to find the y value. So again, if I know the x value and I have an equation with x's in it, I can just plug in negative 1 for x. So f of negative 1 is equal to negative 1 squared plus 2 times negative 1 minus 3. So negative 1 squared is positive 1. 2 times negative 1 is negative 2. And minus 3. So 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. So our y value is 4. So our vertex would be negative 1, negative 4. So hopefully this is starting to make more sense because you're going to have to do this not only on the assignment next class, but also on the test and in the future. So again, x equals negative b divided by 2a. This will give me the line of symmetry equation. So x is equal to negative, b is 10. So negative 10 divided by 2 times a is negative 5. So negative 10 divided by negative 10. So x is equal to positive 1. So here's our line of symmetry equation. And then to find the vertex, I already know that x is 1, so I got to find y by, again, if I have an x value and an equation, I can put that x value into the equation. So f of 1 is equal, get out of here, to negative 5 times 1 squared plus 10 times 1 plus 24. So 1 squared is 1. 10 times 1 is 10. Negative 5 times 1 is negative 5 plus 10 plus 24. When I combine all these like terms, negative 5 plus 10 is 5 plus 24 is 29. So my y value is 29. So the vertex is 1, 29. All right, so moving on. When you substitute x equals 0 into this equation, you get C. So that is the y-intercept. So if I ever need to find the y-intercept, if it's in standard form, that's the one good thing that standard form is good for, or the one thing standard form is good for. If I just plug in 0 for x, it'll easily find a y-intercept. Because 0 squared plus 2 times 0 are both going to be 0. So that means y has to equal -3. So our y-intercept would be at 0, -3. So same thing here, if I plug in 0 for x, that'll tell me the y-intercept. Because remember, the y-intercept, x is always 0, so that's why we're plugging in 0. So y is equal to -7. So 0, -7 would be our y-intercept. So moving on to the next page. So we can accurately sketch a graph by using the vertex, y-intercept, and the average rate of change. So if I wanted to graph this, first thing I could do is I could look at it and say, oh, let's find the vertex and the line of symmetry. So x is equal to -b divided by 2a. B is 4, so -4 divided by 2 times 1, because remember, there's an imaginary 1 there if you don't see a number, times x squared. So I have -4, 2 times 1 is 2, so -4 divided by 2 is -2. So our line of symmetry, which we just found, is x equals -2, and we also know that the x value of the vertex is -2. So then I'm going to find the y value of the vertex. So if I know that x is -2, and I got an equation over here, I can do y equals, instead of x, I'm going to write -2. So -2 squared plus 4 times -2 plus 4. -2 squared is +4. And then 4 times -2 is -8. Plus 4. So 4 minus 8 is -4, plus 4 is 0, so y is going to equal 0. So our vertex is -2, 0. So I know this graph is going to have a vertex at -2, 0. And then how do we know if it opens up or down? So whatever a is a positive or negative in this case? Well, it's +1, so that means it's going to be going up. And since a is 1, I can use the pattern 1, 3, 5, 7, ... It just keeps adding up by 2, but we will never use more than this. So you can always use this pattern, but we have to multiply it by a. But since a is 1, if I multiply all these by 1, the numbers are going to stay the same. So 1 is my first average rate of change. So that means I'm going to go up 1, right 1. And do the same to the left. Next, so I used 1. Next is 3, so that means I go up 3, right 1, up 3, left 1. I just do the same to the left. So these are like slopes. So my next slope or next rate of change will be 5. So I go up 5, 1, 2, 3, 4, 5, right 1. Same thing to the left side. So here's my little U-shaped graph. So I didn't find the y-intercept, but if I had done the y-intercept, I would have plugged in 0. So 0 plus 0 plus 4. So 0, 4 would have been my y-intercept. So 0, 4, which is right here. So that is on my graph. This graph has a minimum. The y-intercept, like we just said, was 0, 4, because when you plug in 0 to x, y is 4. And then the domain, so this goes left forever, right forever. So it's going to be all real numbers. The range is the one you have to really figure out. So it does not go up and down forever. It goes up forever. That's what these arrows here are telling you. But it stops going down. Oops, I hate when I do that. It stops going down at this point right here. So what is the lowest point of this graph? What does y equal at this point? On the vertex, y equals 0, and if you're not sure, you could always look at your vertex, so what's y? And then all these points that are on the graph are all above or bigger than 0. So that means the range is y has to be either greater than or equal to 0. And then example 4, I'll do this one real quick because I know we're running late on the notes again. So x equals negative b divided by 2a. So I get negative 12 divided by negative 12, because 2 times negative 6 is negative 12. So I get x equals 1. So my line of symmetry is x equals 1. The y value, or excuse me, the x value of the vertex is 1. So then to figure out the y value, I plug it into the equation. So this will be negative 6 plus 12 minus 3. Hopefully I'm not making mistakes. Going too fast, so y equals 3. So our vertex is 1, 3. So I go right 1, up 3. That's the vertex. A is a negative number, so that means it's going to be opening down. So my pattern is 1, 3, 5, 7, ... But A is negative 6, so that means I have to multiply all these times negative 6. So negative 6 times 1 is negative 6. Negative 6 times 3, negative 18. And then so on. So that means my first rate of change is going to be negative 6. So that means I go down 6, 1, 2, 3, 4, 5, 6, right 1. Down 6, left 1, because I do the same thing to the left side because they are symmetrical. So if you look, our line of symmetry was x equals 1, so that would be this line right here. That does go right through the vertex and right through the middle of the graph, so that's good. This has a highest point, so it has a maximum. The y-intercept is 0, negative 3, so you could either look at the graph, or you could plug in 0 for x, and whatever y is, you'll get negative 3. So 0, negative 3. The domain is going to be all real numbers, because it goes left forever, right forever, even though it's very slowly. Then the range, y is going to be less than or equal, because all these points on the graph are below this point, or equal to this point. So y equals 3 at that point. So y is going to be less than or equal to 3. So that's the notes for today.